Welcome everyone to this, our second webinar at lunchtime in our series of 6 run by the IOSH Fire Risk Management Group. My name is Michelle Pitkin. I'm the Vice Chair of the Fire Risk Management Group, and it's my pleasure to introduce to you Neil Vincer, Chair of the Fire Risk Management Group, Ian Scott, a member of the committee who will be assisting us this afternoon, and Anne Isaacs, who is our speaker for this lunchtime webinar. Many of the webinars that we've seen over the past 18 months have centred on subjects that are of interest to more experienced occupational health and safety practitioners. Many of the comments or questions that we've received have come from the less experienced practitioner, either young members or members who are just starting out in the profession. This series of webinars are primarily aimed at those who are less experienced in the field, but hope that it will also serve as a timely reminder, a refresher to those who have been in the role for a little bit longer. In today's Back to Basics session, we'll be looking at the basic principles of fire safety. If you have any questions throughout the presentation, please pop them in the Q&A function. We may in fact cover some of your questions in later webinars, but we will answer as many questions as we can. This afternoon's webinar will be available on the IOSH YouTube page and alongside the Fire Risk Management Group microsite. Copies of the slides will also be available. And so to our presenter this afternoon, Anne Isaacs. Anne has spent more than 26 years managing student accommodation and now manages a residential estate of 211 luxury flats. Anne's role involves all aspects of facilities management and health and safety, allowing Anne to use her experience, knowledge and skills in the ever-changing environment. Anne joined IOSH 12 years ago, initially volunteering for the London Metropolitan branch, holding various positions, including chair. Anne is currently a member of the IOSH Fire Risk Management Group. She is a council member and a trustee of the IOSH Benevolent Fund. Outside of IOSH, Anne volunteers as a school governor, a new role to her that she is relishing and finding exciting. When time allows, Anne likes to read, write poetry, and is also teaching herself to play piano. A truly well-rounded individual. So now it's my pleasure to hand over to Anne for this afternoon's webinar. Over to you, Anne.
Thank you, Michelle. And good afternoon, and good evening, and good morning, wherever you are in the world. This is the second in a series of modern fire safety presentations. It addresses the principles of fire prevention. Other presentations to follow in this series include principles of fire investigation, principles of designing for fire safety, including fire safety management systems and fire risk assessment. The first series, An Introduction to Fire Safety, was presented by Ian Scott on the 14th of October, a recording of which is available on the IOSH web pages. This course addresses the causes of fire, looking at what causes fires, how to recognise hazards, assess risks, and prevent fires, detection, warnings, alarms, what action to take safely, how to reach safety with others, and how later to put actions and conditions right. If you're watching this presentation alone, then the usual domestic arrangements may not apply, but do take a break halfway through. The presentation accompanies the big red book of fire safety, and the notes pages contain additional information too. So if there's one slide to remember, it is this one. Most fires at work are preventable. If a fire does break out, the effects can be devastating. Make sure that you know how to prevent a fire and what to do in an emergency. This slide shows the fire triangle. You can break the triangle by removing sources of fuel, sources of heat or ignition, and removing sources of oxygen. As we shall see later in the science or chemistry of fire, how we can break the fire triangle by disrupting the fire process chemically. The slide also reminds us about the basic types of fire extinguishers that are available. Employers and building owners or occupiers must carry out a fire risk assessment and keep it up to date. If your workplace contains flammable liquids or gases in storage, a special assessment may have to be done under the provisions of DESIR Regulation 2002. DESIR stands for Dangerous Substances and Explosives Atmospheres Regulations. The best thing to do is to try to avoid the risks with safe control measures. The fundamentals of good fire precautions comprise some of the following: good housekeeping, avoid the buildup of rubbish, install an appropriate fire alarm system, carry out regular drills, ensure the fire exits and escape routes are clearly marked and unobstructed. Here's a nice welcoming fire, but not all fires are as controlled as this one. This deck addresses the fundamentals of fire safety, which comprise fire prevention and fire precautions. Fire prevention, how can we manage that? First, we need to stop the fires starting in the first place. Control the means of ignition through good housekeeping, which is essential. Limit fuels that can burn. Manage stock control and efficient waste management. What precautions can be taken? You need to have systems in place that can detect a fire and raise an alarm. You need to have a means of escape which will not be compromised by smoke and will lead to a place of safety, i.e. a clearly identified assembly point. Fire suppression systems, i.e. extinguishers and or sprinklers, need to be in place. Fire drills will need to be carried out, ensuring that relevant training is provided for key staff. Inspect the workplace/building regularly to identify any maintenance issues that need to be addressed. These items and more will be outlined in your fire risk assessment, which you must have. We have seen the fire triangle before, so we can remind ourselves how now of the three elements. Fuel burns and gives us products of combustion. Heat gives the fire a means of ignition, and oxygen gives the third element of the combustion process. For a fire to occur, there needs to be a combination of fuel, air, and the means of ignition. In order to stop a fire occurring in the first place, we need to break the fire triangle by removing one item. Measures in place in buildings aim to control the risks of fire starting. Primarily, this involves the use of materials that are tested not to ignite. For example, carpets, chairs, and other items used in buildings. Sources of ignition are controlled, including lighting and electronics, typically through operational procedures that are put in place to control the type of electronic items being used. This is the definition of fire prevention, which talks about the measures aimed at preventing outbreaks of fire and avoiding danger and damage to persons and property. Fire prevention and its twin with fire precautions are at the heart of fire safety. Essentially, these comprise the steps you take to prevent uncontrolled fires from breaking out in the first place. If a fire starts, the measures that you have taken to mitigate the effects and stop the fire spreading, warning people that the fire has started and getting them out of a building to a safe place. This is the basement under a school. The illustration here focuses on one of the most significant aspects of fire prevention, which is good housekeeping and tidiness, particularly in storage. There are practical measures that can be undertaken to dismantle or disrupt the fire triangle. Training should be provided to support people and bring about awareness which will go a long way to preventing unconditional fires. So what steps can you take regarding the storage and disposal of hazardous substances, also known as chemical safety? Firstly, chemicals must be stored correctly, i.e. not storing acids and chlorine together. Every effort must be taken to observe storage classification. The uncontrollable storage of chemicals is never permitted. There are rules that apply to all hazardous chemicals. For example, an essential COSH assessment must be carried out for each chemical. The COSH assessment form is available free on the HSE website at hsedocs.com. And COSH stands for the Control of Substances Hazardous to Health. Chemicals are to be stored correctly to avoid spillage. Trained staff working with these chemicals must wear appropriate PPE. Escape routes and emergency exits must be kept clear. Suitable dry powder extinguishers and first aid equipment, including IOSH bottles, must be available. In terms of disposal, never dispose of chemicals down the drain. Chemicals are to be disposed of responsibly by a reputable waste disposal contractor. Relevant chemicals should be in a locked cabinet. Material safety data sheets should be available to give details of correct storage guidelines and other safety information. Solids and liquids, flammable and non-flammable, acid and alkaline chemicals should not be stored together. Only trained individuals are allowed to use hazardous chemicals. A good hygiene regime should be in place. There's a risk of the buildup of fumes, so a good ventilation is required and spill kits should be available. Items should be stored in a cool, dry atmosphere. Do not store more than you need. Think about your stock control. Labels should be facing forward. Heavy items placed on lower shelves. Looking at this store, we have items with red labels, which are flammable chemicals, black and white labels, which are corrosives, yellow labels are oxidizers, and the ones with orange band are general purpose chemicals. The key fire prevention issues are in the proper, safe storage, transport, use and disposal of chemicals, which is vital in ensuring the ongoing safety of health of staff, contractors, clients and the public. Here is key information from the Chemical Business Association on a colour coding scheme for chemical containers. They are proposing that all chemicals are packaged and distributed in standard colours. The website for this, for the Chemical Business Association will be in these notes, which will be available later on the website. This slide shows a classic solution to the safe storage of gas cylinders. A very good example, as they are using the CBA colour coding. The stock is reserved for LPG only, although it would be permitted for other fuel gases, such as hydrogen, to be stored in a segregated area of the same cage. However, one would never store oxygen or other oxidizing gases in the same cage. Incompatible gases must be stored in separate cages or stored in separate locations. Note the cage doors are secured with a padlock, and if possible, separate storage should be reserved for full and empty cylinders. The old trick of writing the letters N and T, M and T in chalk on empty cylinders doesn't work in the rain. Open air storage in a naturally well ventilated place is good, and the store must be located away from opening windows and doors. Note the signposting and the HazChem code for the firefighters on the side. The traditional orange and black symbols on the left have now been superseded by the GHS symbols, and GHS is globally harmonized system. It's worth noting that 2 sets of pictograms are included within the GHS, one for the labelling of containers and one for workplace hazard warning signings, and the second for use during transport of dangerous goods. The consequence of fire is never far away from chemicals and reactive substances, as the hazard warning labels show. This poster is designed to help employees identify the hazardous nature of chemicals through recognition of the symbols. I will point out that there are a series of actions/conditions that can cause fatalities: human error, mixing the wrong chemicals, lone working, manual handling issues, spillages, secondary effects such as the outbreak of fire, which would cause some chemicals to explode. You may not consider that building a lovely powerboat like the Princess Yachts international offshore cruiser such as this could put someone's life at risk, and especially from fire. However, Ben Pinkham, an apprentice, aged 21, was cleaning a glass-reinforced plastic resin storage tank with acetone and knocked over a halogen work lamp, an obvious source of ignition. The flammable solvent ignited, Ben suffered 90% burns and died 3 days later. The contractor's managing agent, Alan Mark, was jailed for 12 months and his business was fined £90,000. Ben's employer was also found guilty of manslaughter and fined for health and safety offences too, but no separate penalties were levied. When dealing with any flammable liquid, acetone is one of the most flammable in use as an industrial solvent. Process safety risks are utmost and must be supported by robust risk assessments and safe systems of work. It's always worth thinking about changing the process. Perhaps consider substitution using a less hazardous substance or changing the method or materials and minimize quantities, as well as thinking about possible sources of ignition. Looking at this, was this in the building designer's mind? Was storage even ever thought about? Here, this electrical switch room, which contains power switchgear and circuit breaker boxes. This is a brand new school that had turned a switch room into an improvised stationery cupboard. This slide shows the opposite wall of that electrical room. The combustible materials have been neatly stacked around the electrical switchgear of the distribution system. Again, in this situation, everything starts with the fire risk assessment. Identify the hazards, work out to minimize or eradicate the risk. Electrical and mechanical safety is vital. The obvious risks are highlighted in this slide. Fire caused by overloading electrical socket, electric shock. This could be due to lack of training, vandalism, or incorrect installation. The unsafe use of extension cords. The cuboid socket, as you can see in the bottom left, was broken. It was still being used despite the live connections being exposed. This picture shows the dust in a desktop computer. You can only imagine the results will start with overheating. The second picture, a fire, the result of a grease-filled extraction unit. The buildup of grease, think back to the fire triangle. The grease being the fuel, combined with heat and oxygen, leads to combustion. If we eliminate the dust from the computer, the grease from the extraction unit, and having a regular cleaning regime, these incidents will be prevented. This picture shows a storeroom. The fire alarm system has been disabled, a power socket has been dismantled, and the fire escape's been blocked. This is an incident waiting to happen. This is University Hospital of North Durham. Newly installed electrical switchgear brought on by the increasing demand for extra power. The installation was done by a trusted manufacturer in the hope that they would do the job properly. Loose electrical connectors were vibrating at 50 Hertz and arcing, not torqued up properly at the time of manufacture, although the QC certification and completion certificate said this had been done. Faults were detected through poor electrical current supply and current fluctuations. Excess heat from poor electrical contacts caused smouldering and high temperature melting of the switchgear. Heat damage can be seen on the copper conductor. Expert knowledge and intervention by the AP Electrical prevented the overheating and the breaking out of a fire. Just get a drink, sorry. Following on from the previous slide, the same series of incidents, a real electrical flashover occurred. During installation of the new switchgear, cut armoured cable debris was swept on the electrical cabinet by the electrical fitter, as opposed to being swept up and disposed of properly. You can see that in the picture on the right. The cabinet door was opened live to investigate the condition of the switchgear, inadvertently sweeping the loose debris from the cable armour up into the ventilation grill. The switchgear arced when a strand of wire shortened the buzz bars, as you can see the results in the picture on the left. Fortunately, the electrician was experienced. When he opened the cabinet door, crouching down, using it to shield his face. This was just as well. The flash from the arc would have caused serious injury, as he was not wearing any PPE or eye protection, and even worse, he did not tell anyone where he was. This is Coatbridge School, North Lanarkshire. As a local sustainability initiative, electrical installations were manufactured by local contracting companies. The wiring looms from the ceiling lights used screw-down chocolate box connectors instead of crimped terminals. The installation powered the electrical lighting circuits in the void above the suspended ceiling. One of the connectors on the left was not fully screwed home, and the end of the conductor showed arcing, which caused this fire. Machinery maintenance is vital in fire safety. Even a 26-ton machine needs to be properly maintained to prevent fires. Here, the battery and electrical supply systems to the vehicle were suspected of being the source of the ignition. At the time, the vehicle was undergoing heavy maintenance in preparation for the winter gritting season. Again, the consequences of fire can be far-reaching if they are not prevented in time. For example, the roads may not have been gritted, and there's also the issue with the impact this incident would have had on the business. Fortunately, the man managed to get out of the van in time. So this is the scene of a fire, a personal experience that I went through. So I was managing, as you can imagine, managing residential buildings is a challenge, as there is the added risk when people are sleeping. Student halls, the fire alarm is renowned for going off regularly. As Michelle mentioned earlier, I've spent a large chunk of my career managing student halls. When I came to manage a student hall in London, the first year we had 32 AFAs, and that stands for automatic fire alarms. I'll use that abbreviation as I go through. At the time, London Fire Brigade was suggesting that businesses should be charged about £270 per appliance to attend AFAs. And because it's a residential building, 2 fire engines had to turn up. So just looking at the calculation at 32 AFAs, that would be an expenditure of £17,000, £17,000 of unbudgeted expenditure. So on closer examination of the record, so I looked back over the previous year of what caused those AFAs. And predominantly they were caused by dirty grill pans, dirty greasy grill pans. Students would come back from a night out wanting to make burgers or whatever, and they'd put the burgers in the grill pan full of grease, which would then they'd go off to their bedrooms. The kitchen door would be propped open and it would be smoking away, filling the kitchen with smoke, and then the smoke would go onto the corridor, setting off the alarm. The next year, within the first week, we put in a regime that all the students were given fire awareness training by the fire brigade. A stringent checking regime was implemented. So we had student assistants, then some places call them wardens. They would carry out weekly checks of all 73 kitchens, and I armed them with AIFireE liquid. So the idea that if they came across a dirty, greasy pan, the pan was put in the kitchen sink and the AIFireE liquid was squirted on it. And that meant the next person who wanted to use it had to wash it. As part of that regime, they had to check the smoke detectors, because students were also renowned for putting socks over the detectors. The fire equipment was checked, the kitchen doors were checked, did they fit into place? And the corridors were also checked as well, because that's the escape route which had to be kept clear. That year, the other thing that happened, any maintenance that came out of that checking regime was dealt with really quickly, and it had to be, because I made sure that nothing was broken around the hall. That year, our AFAs were reduced to 6. It was great. The impact of this was that students were no longer complacent around the issue of fire safety. Fire drills were much swifter than in previous years. Many of the second and third year students were really complimentary of that change, because they remember the constant false alarms from the previous year. Then one night about 2 a.m, the fire alarm went off. I jumped out of bed, got dressed, checked the fire panel in my flat, because we had a fully addressable system that told me the exact location of the activation. When I arrived, many of the students had already evacuated. I went inside, it was a ground floor kitchen. I walked down the corridor, half expecting it to be the usual grill pan issue, only to be confronted by a massive blaze. I left quickly. I will point out that there was no smoke on the corridor. The kitchen door fitted properly into the frame, and the intermittent strip did what it did. It contained the smoke and the fire. When I actually checked the fire panel again, it actually showed it was the heat detector in the kitchen that had activated the alarm, which meant that the temperature in that kitchen was more than 59 degrees. The pictures that you can see I took, they don't really show the devastation that was caused by a student who had put on a pan of oil to cook chips, and then he went back to his room and fell asleep. We've been talking about prevention. As we all know, prevention is better than the cure. Carrying out regular checks ensured that everyone could evacuate safely. Carrying out regular checks ensured the fire equipment worked, reduced AFAs and prevented unwanted expenditure. There was also reduced complacency regarding the issues around fire precautions. So we can summarize fire prevention by saying that it is process-driven, rule-driven, and behavior-driven. It is process-driven through occupational, environmental, and human factors. Rules have to be set to control what people do, where, and how. Behaviors have to be exemplary. Managers, staff, contractors, and operators must be well trained. Fire is a fatal risk in all walks of life. The consequences can be terrible. Don't be complacent about fire precautions and never ignore warnings or take any risks. If in doubt, get out. I would always tell my students that the smoke will get you long before the flames are licking at your heels. Never ignore principles of fire prevention. Remember the fire triangle. Minimize fuel and sources of ignition. Good housekeeping is vital. Learn the drill. Know your escape routes. Take care of your family, friends, and colleagues, and help them with your knowledge and skills. Thank you.
Thank you, Anne. That was a great presentation. We've had lots of comments coming in, and we've actually got quite a few questions that we would like to try and answer with yourself and Ian, if we can. If you bear with me, I've just got to bring up my screen. So the first question, and we've had a couple of questions on this subject, is around the big red book on fire safety. Can you give advice or a direction that people can access this information in?
Can I pass that question to Ian, please?
Thank you, Anne.
Either of you.
The Big Red Book is a document we're working on at the moment. It is encompassing all the presentations that have been given in this series, or are going to be given in the series, and goes into much more detail as well on lots of technical aspects to help people. There are many textbooks on specialist parts of fire safety, but we've tried to address this from a back to basics approach for those who are, as you described at the beginning, Michelle, starting out in their careers, etc. So hopefully that will be available very soon. It's best not to send it out before we've done the verbal presentations, as it were, but we trust that people will find it interesting, and we'll publish it shortly.
Thanks, Ian. So the next question comes in, and it's around the fire strategy document. What information should be included within the fire strategy document, and who should compile this document? So either Anne or Ian would like to answer that one.
Well, I think I'd start with the responsible person or any managers that would need to put that document together. I mean, the fire strategy document is about what you will need to do in the event of fire and everything that it needs to contain in there. So the fire risk assessment needs to be in there. And in my last building, we had a very, what's the word I'm looking for? A building that was very, it was built for safety. It was very intuitive. Everything, when the fire alarm went off, various things happened. So in that document, you need to know how your building is going to react. Ian, do you want to add anything to what I'm saying?
Yes, thank you. Also in terms of strategy, it's starting with the fire safety policy and working through what you would now call a fire safety or a fire risk management system. And within that, as people have touched upon before, we talk about what information, instruction, training and supervision you would want to put in place, much as you would in any other aspect of general occupational safety and health. And as Anne said in some of her words earlier on the slides, people do assessments under the COSH regs in terms of occupational health and the processes that are undertaken, and also process safety assessment or DS, EAR regs assessments. And you'd want to include those as well. So you have a full picture. It's a total inclusive package of knowledge, understanding and application in dealing with fire safety and the world of work where people are potentially at risk from the fuels or the means of ignition, sources of ignition, which they face in the place where they work.
That's great. Thanks, Ian. I hope that's answered your question there, Shane. Our next question is some clarification, if we can, to clarify the difference between COSH and DESIRE.
So COSH is the control of substances hazardous to health, and that deals mainly with chemicals. And DESIRE is about the management of fire and the reaction in all aspects of a building and with chemicals and anything. I think that is probably the simplest way that I can disseminate the two. So the COSH and the COSH assessment will tell you about what chemicals, and the COSH assessment will also show you what to do if you've managed to spill it on your face, how to store it, and what not to mix it with and how to deal with it in a fire instance. Is there anything we need to add to that, please, Ian?
Yes, the way I remember the difference between the two is the acronym for COSH. It's substances hazardous to health. So the hazardous ones are the ones which affect people and the roots enter to the body and such like. Whereas the dangerous substances are the ones which have the potential to burn, as it were, or be acidic materials or whatever, process safety driven requirements. And in a way, the two are mirror images of each other. There is common ground between both sets of regulations in the approach to dealing with materials, but also in the solutions that you would want to employ. And Anne, as you pointed out clearly in the presentation, if you are separating and segregating materials in a particular way because of fire safety requirements, then whatever you do there is probably going to be extremely beneficial to the health of people when they come to handle materials or such like. Examples also include things like manual handling. And if you're moving, for example, gas cylinders, you'd always put them on a gas cylinder trolley with a chain and such like to ensure they're safe and stable when they're being moved around. And of course, that will have fire safety benefits because the extinguisher, the cylinder hopefully will not fall over and the valve snap off, which can be quite disastrous.
Thank you, Ian. Thank you, Anne. So we move on to evacuation and a question around evacuation from Kevin. So Kevin is asking around the time of evacuation. So we say that everybody should leave as quickly as possible, but what would you suggest is a reasonable, acceptable timescale for the emergency evacuation? Is there a specific time stated in legislation?
I don't recall seeing it, but if you're talking about, that's a very broad question because it depends on the building. I mean, we could have a building, it could be a hospital, it could be a school, it could be a shopping centre. So the time for evacuation, that's how long's a piece of string. I mean, I was at the school the other day and we did our fire evacuation. The school of 1,400 students was evacuated in 4 minutes. But again, in the other evacuations that I've done, the hall that I used to have had 423 students, 7 minutes. So it's different for different buildings. And if you're thinking about a hospital, you know, they've got to think about the beds and the people. You can't really put a time on it as long as it's done as quickly as possible. I think that would be the best, quickly and efficiently as possible without panic. I think that's all that you can hope for.
Okay, thanks, Anne. Did you want to add anything to that, Ian, in your own experiences?
It's a very good question, very interesting, actually. So thank you for the interesting question. I agree with Anne. I don't, it's extremely difficult. It is the length of a piece of string. We have things like travel distances from where the person is in the building to the fire exit or the means of escape. And if that is a long distance, then part of that route which somebody would follow would have to be protected in some way against the effects of fire, if that was the case. Yeah, I think you would also be interested in trying to avoid a very popular word at the moment is complacency, where people think, well, it could be it could be a fire drill. It's a Thursday. We always have a fire drill on a Thursday, so they're not quite sure. And then suddenly, of course, they start to smell the smoke, or they see the flame, or whatever, and think this is not a drill. We need to get out. And as Anne said from the slides, if you're in any doubt, get out. Is the simple, in my opinion, simple view behind all this. Never take the risk. Help other people if you can, and make sure you get out of the building and get to the assembly point as quickly as you possibly can, and report to the person who's in charge there to be accounted for.
Great, thanks guys. So we're now moving on to gas, LPG, and you mentioned that during the presentation about full and empty storage. So two questions that have come in very similar on the same line. So how far apart should gas cages be located? And what and why is it critical to separate empty and full LPG cylinders?
Right, shall I kick off?
Yeah, well, you can help me out with this one, Ian. Yeah. But the first thing is, I would say, as far away as possible for the for the containers, and as long as they're not near any doors or windows and what have you not. Ian?
Yes, I absolutely agree with you. So there are requirements, there are specified values in the guidance which the HSE produces, and also the manufacturers through their trade body, British Gas Association, people like Flow Gas and Calagas. So they will specify distances away from entrances to buildings, and that could be simply doors, but it also could be opening windows. You'd want to keep cylinders separated if some were full and some were empty, simply to avoid any potential confusion. And we know that safety-related incidents or accidents occur when things change. So if a guy comes along with his truck to come and collect cylinders and take them away and such like, it just makes his job easier if he knows that this is the place where empty cylinders are stored, and this is the place where he has to put the full cylinders he's brought with him. And then people won't be confused getting the wrong cylinder out, having to put it back because they take it to where they need to use it and connect it up and find it's empty. So it just avoids unnecessary confusion and reduces, in my opinion, actions and conditions which could give rise to an accident. And it's not just simply the manual handling type issues, but as we mentioned earlier, if the cylinder is dropped, it could be damaged. And potentially, if the valve is damaged, there is a very significant problem indeed. Regarding the distances, have a look at the notes which will accompany the presentation. We've got details in there of the references, particularly to the HSE's advice and guidance on storage of LPG cylinders.
Lovely, thanks, Ian. I'm just waiting for some questions to pop up. We've got 73 questions. We're not going to have time to answer them all, but please be assured that after the webinar, we will come back to you and answering all the questions that have come through to us. Here's one that's a little bit different, but Anne mentioned dust during the presentation about the buildup of dust and how that can potentially be a fire hazard. So Rob asks, how would you prevent large dust buildup inside a computer, as we saw in the slide there, Anne? Ian smiling.
Yep. I bought a new computer.
Other than buying a new computer?
Well, other than buying a new computer, the issue with those computers, it would be to open it and check it. I mean, yes. Even when the guy comes around with doing the pack testing, we can open it and check it, because not only that, the fan would overheat, so it would also have given rise that something is wrong. So open it, check it, and give it a good hoover. Yeah,
it's a very good question indeed. So thank you to the person who's asked the question. The dust in the computer one is just simply an illustration, and it's a pretty obvious illustration, but we may not think about it all the time, of maintenance of machinery, and that's simply what it's about. Dust is invidious; it will get anywhere, particularly with IT type equipment which uses cooling fans. It can be drawn in. You can now, if I could turn the camera around here, you'd see on the front of this desktop machine. It does actually have a dust filter as part of the design of the machine. It's a a replaceable or washable filter on the front, and it recommends through the BIOS of the computer every month or so that you take this thing off and vacuum it and clean it. I have actually done that, and it's surprisingly dusty. Even laptop computers, because they have generally cooling fans in them, even with solid state drives, do draw in dust from the workroom or the atmosphere or the office or wherever you are. So they will build up as well. But you'll also find you get, as Anne points out, you'll get performance issues with the computer. If it starts to overheat and such like, it will probably tell you, it'll trip out. And if you find that happening, then take it to your local IT specialist, or if you work for a business who have an IT department, and get them to give it a good vacuuming out. Resist the temptation to put a compressed air line on it and blow the dust out, because that goes everywhere and becomes a bit of a respiratory hazard to everybody working nearby. So you can get micro attachments for vacuum cleaners to suck the horrible stuff out. But it's simply an illustration of the requirements to properly maintain big machines, and also to make sure that ventilation grills are clear and functioning and keep machinery cool.
Lovely, thanks, Ian. We've just got one about signage. So final exits must be equipped with signage, which we know, but the signage in question, does it need to have a running man with a directional arrow, or is the running man alone enough?
Now, from memory, the fire exit signs and the whole signage regulations changed, and it depends where you are in the world. That's the first question I'd ask. If we're talking about British standards, the running man we have, and the arrow, but there is the standard of exit signs, which at this moment in time I should really look up and remind myself of what it is at the moment. And I know that Ian is going to be able to tell me what the latest one is.
Well, all I would say is, when you are walking around a workplace, or if it's a larger industrial facility or a larger infrastructure type building, a shopping mall or something, you're always looking for direction to go places. So if you're in a particular place and you're looking for the fire exit, then you will see directional arrows. This is the way I try and remember it. So here you are sitting down and you're thinking, well, where do I go? You might find a suspended sign, you'll find a sign on a wall. It'll give somebody a direction, left or right, or straight on, or down the stairs, or an inclined arrow, or whatever. And then by the time you get to the final exit from the building, you would have, a big sign which says fire exit. You've got to your exit now, and you go through that and reach the place of safety or the assembly point beyond. So it's a mixture really of identification of the final exit from the building, but also in wayfinding of getting there from where you were at the time. And particularly if you stayed in a hotel or in a conference center or whatever, you'd be very, very keen to find out from the little map or plan on the back of the room door which way is the fire exit. You go out, you leave that particular room, and you're looking for directional arrows to point you in the direction of the fire exit. And then when you get there, that will clearly have a sign on it as well to assist you in getting out of the building. Sometimes the signs, almost certainly would be supported by emergency lighting and illuminated signs, or even photoluminescent ones, which glow in the dark cheerily as well. They're very good.
Just on that one, Ian, you just mentioned about the glow in the dark ones. One of the questions that has come through is, do fire signs have to be glow in the dark, or is it just seen as best practice? So I'm glad you mentioned that there. Thank you.
Well, I think it's best practice. It's a great idea. it's a piece of technology which is entirely beneficial. You know, I don't see any disadvantage in having that sort of glow in the dark sign. It's a really useful thing to do. Just as any wayfinding sign would be, actually.
Yeah, no, that's great. I think that it's the same consensus there from both of you. So yeah, lovely, thank you. Just keeping an eye on time, I think we've probably got enough for maybe a couple more questions. Just again, if we don't get to answer your question today, we will be answering them all after the webinar. I can now see that I've got 96 questions open. So as I say, I think we've got time for a couple more. The one from Stephen's come in around best practice to account for all people evacuated from a building. What is the best practice to account for all people having evacuated from a building? And with the numbers of students that you've been dealing with, have you found something that's worked best?
Well, the first thing, again, I'd say it's about the building and the usage. And for argument's sake, this was a question we had the other day when we did the fire drill at the school. So they've got sixth formers. So up until sixth formers, those children have to stay in the school, but sixth formers are allowed to come and go. So how do you account for anybody if you don't know that they're there? That's the first thing. And in the past, we've had a tick register, but there's modern things now. They've got electronic tap-ins where you can just run off the register of who's in the building. But it really depends on the different types of buildings. For argument's sake, like where I am now, I have a register that everybody signs in when they arrive for work. If the fire alarm went off, I would grab that register because they've signed in, and I'll be able to see who was there. But the only downside with that is if somebody forgets to sign in. It's a human error. Always, you can put in what system you like, but there's always that element of human error that somebody doesn't sign in. So even if you have a list, you have you tap in and somebody doesn't tap in and you run off your list, there are so many factors that can, you know, trip up your best laid plans when you want to check who has actually evacuated the building. So do the best you can, have your list, whatever system you've got, but just be mindful in the back of your head about what people will do, especially when you know there's people who don't tap in or sign in regularly. Those are the ones that you probably need to look for.
Thanks, Anne. Any experience from yourself, Ian?
Yeah.
Just finally.
Fine, thank you. There are two or three things that come to mind straight away really on this, and touching upon what Anne has just said there. It all depends who your audience is, who are the people, you know, if it's school children, if it's students, if it's people in a shopping centre, if it's people at a large show or exhibition or a concert or whatever. I personally like the idea of having fire wardens who sweep the floor, who are there to literally corral everybody out, and they can be quite firm in what they say. You know, you must leave the building, you must leave it now, leave things behind. The only thing you're allowed to carry are children if they need to be carried. So that's one way of doing it. One particular thing I'm interested in is looking at the advantages of new technology, and again touching upon what Anna said there, also where people have an identity card or whatever, which gives them access, a security control access into the building. This is a large corporate type environment. You could use radio frequency identification these days. You tap the card to get in, it logs you onto the system. If the fire alarm goes, then somebody will have a reader, and you can, you know, interrogate the lanyards, the identification badges of people when they arrive at the assembly point. But I think there is nothing, in my opinion, there's nothing better really than looking out for each other. As Anne said at the end of one of her slides there, it's helping people with your knowledge and experience, and you know, an extension of that is physically helping them as well. You know the people you work with, you know who's in today, you possibly made them a cup of tea in the morning or whatever, and they've got something for you. So you know who your workmates are, and who your colleagues are, and who's in the building, and it's keeping an eye open to make sure that George, Eric, or Mary are actually on the route out of the building as well, and taking care that they safely reach the assembly point.
No, that's great advice there, Ian. As you say, you know, you can have every system going, but you can't beat looking out for each other. With that, I am going to draw the webinar to a close. We have 105 questions still unanswered, but please be assured after the webinar, we will be working through those and we will come back to you. As I say, the presentation will be available on the IOSH YouTube page and the Fire Risk Management Group microsite. I would just like to promote our next webinar, which is on the 30th of November at 12 o'clock. We will be discussing the new Fire Safety Act, which received royal assent on in April 2021. We will be discussing the changes that have come about and what they mean to you within the field of fire safety. So we hope you can join us for that. We will be running our third Back to Basics series on the 9th of December, where we will be looking at fire precautions. That's at 12:30 UK time. So we look forward to seeing you again then. But for now, I'd like to thank you for joining us. I'd like to thank Anne for the presentation this afternoon, for Ian, his assistance in the question and answer session, and for Neil, who has been frantically working behind the scenes, trying to answer as many questions as possible. But lastly, I would like to also thank Dimple, who has ensured the smooth running on the technical side of this afternoon's presentations. So thank you all again for attending, and we look forward to seeing you on the 30th of November at 12 o'clock for our lunchtime webinar on the new Fire Safety Act. Thank you. We'll see you soon.
Thanks, Michelle.